Every system design interview includes a load balancer. Here is how they actually work and why you need to know the difference between L4 and L7. Load balancers, L4 versus L7. High-level design, day 3. A load balancer sits between your clients and your servers. Its job is simple. Distribute incoming traffic across multiple servers, so no single server gets overwhelmed. If one server goes down, the load balancer stops sending traffic to it. This gives you both reliability and performance. Every production system you use, from Google to Netflix, has load balancers in front of their servers. There are two main types. L4 operates at the transport layer. It only sees IP addresses and port numbers. It makes routing decisions based on that alone. It is fast because it never inspects the actual content. L7 operates at the application layer. It can see HTTP headers, URLs, cookies, and even the request body. This makes it much smarter. It can route /API requests to your API servers and /static requests to your CDN. The trade-off is that L7 adds a bit more latency because it has to parse the content. Load balancers use different algorithms to decide which server gets the next request. Round robin is the simplest. It just rotates through servers one by one. Server 1, then 2, then 3, then back to 1. Least connections is smarter. It picks the server that currently has the fewest active connections. This is better when requests take different amounts of time. IP hash takes the client IP address and hashes it to always map the same client to the same server. This is great when you need session stickiness. Let us look at L4 in detail. When a TCP packet arrives, the L4 load balancer sees the source IP, destination IP, and port numbers. That is it. It performs a NAT translation, changing the destination IP to one of the backend servers, and forwards the packet. It never opens the packet to look at the contents. This makes it extremely fast, with microsecond level latency. Think of it like a mail sorter who reads the address on the envelope, but never opens the letter. L7 is the smarter sibling. It actually reads the HTTP request. When a request comes in, the L7 load balancer inspects the URL path, headers, and cookies. Based on rules you configure, it routes /API requests to your API server pool, /auth requests to your authentication service, and /static requests to your CDN. It can also handle SSL termination, meaning it decrypts HTTPS so your backend servers do not have to. This is where you get A/B testing, rate limiting, and authentication routing for free. So when do you use which? Use L4 when raw speed matters. Gaming servers, video streaming over UDP, or any high-throughput TCP workload where you do not need content inspection. Use L7 when you need smart routing. Microservices with path-based routing, A/B testing with header-based routing, or any system where you need SSL termination at the load balancer. In the real world, most web applications use L7 load balancers like Nginx or AWS ALB. L4 load balancers like AWS NLB are for specialized high-throughput use cases. 5 things to remember. Load balancers distribute traffic for reliability and performance. L4 is fast but blind to content, routing by IP and port only. L7 is smarter, routing by URLs, headers, and cookies. The 3 main algorithms are round robin, least connections, and IP hash. And always mention a load balancer in your system design interview answer.